আমি দেখিয়েছি অলরেডি যে কিভাবে আমাদের ক্রেডিট ভ্যালিডেশন প্রবলেম কি এবং কিভাবে সেটা এটা আমি আগের দিন বলছিলাম যে what is actually doing at the hidden layer actually. So hidden layer is actually the feature detectors. Hidden layer is acting like feature detectors, and let us say it is a high level feature detectors. So if you look at this image, this image is actually
স্যার আপনি মনে হয় স্ক্রিন প্রেজেন্ট করেননি।
oh, sorry. Okay, now is it okay?
Yes, sir.
Now, so this is your input image. The left side is nothing but a collection of pixels, and the pixels are actually the white pixels, and there are also the black pixels. So it is actually the image that can be represented by this kind of a collection of pixels. So it is actually if you consider, if you submit the pixel values one by one. So now the three white pixel, 1, 2, 3 is the three white pixel. Then 1, 2, 3, this is the black pixels, this row, and then there are one white pixel and many black pixel and then one white pixel and so on. So if you go row by row and if you submit in this manner, then it should be actually the input to the input layer. Now, what would be actually formed? I mean, what would be actually learned at the hidden layer? So that can be that it is the not the only one hidden layer. It may have a multiple hidden layer also, and different hidden nodes may learn the different features of the input image. Just to take an example, say for example, it is your input image, and it is the linear representation of this two-dimensional image. It's a linear dimension. It is a node. Okay, so for this node, say this dark connection is actually are actually having the strong connection. I mean, is assigning the more weight, and this connection, I mean, which is not dark, there is a small, narrow yellow connection that is actually zero weight or low weight. So if it is actually assigned, or neural network actually assign this weight, higher weight to this connection and lower weight to this connection, it will actually essentially learn a certain features. I mean, this horizontal line, this horizontal line, this horizontal line will be actually learned by this node. Similarly, this is the horizontal line, this will be learned. Now, but if these are the darker, this connections becomes darker, I mean, get the more weight, and the other connection get the low weight or zero weight, then this node will learn these features, this portion of the image, and thus the different node of the neural network, hidden node, will learn the different types of features. I mean, the vertical lines. This is one type of feature. Some nodes will learn the vertical lines, and also the horizontal lines. This is the horizontal lines. Some nodes will actually learn these horizontal lines, and some node may learn the circle of the image, and there is some also the issue related to the position invariance, because it is inside the box. So it is this image is actually covering the entire box, but sometimes somebody can write this image a little bit upward part of the box and on the lower part of the box or left portion or the or the or on the right portion. So in that case, what would be the can the network will be able to identify that test data? So if this 2 is written, all the 2 is written is covering the entire box. But whenever during the testing, if the 2 is written this portion, a small portion like this 2 here, then what will happen? So this is the issue, which is actually known as a position variance or position, whether the network is position invariant or not. But that is the more sophisticated network is actually required to deal with this issue. So I am not actually going into the detail of how this problem can be position variance problem or position invariance problem can be solved. So I am not going into the detail of that. So if you take any course on deep learning online, then you will be able to find out, you'll be able to understand how the network can be actually make the position invariant. However, so what we would I like to say is that the network, the hidden nodes will actually learn the different portion or different feature of the input images. And whenever some and the outer node, I mean the outer node, will combine those features to form the higher level, more and more higher level features. So so just to look at this, so in this detailed line in specific position, so these are the different features that has been learned by this node at this level, and a higher level detect a horizontal line, a vertical line, loop, and these are actually learned. Okay, and now what does this unit detect finally? So now this information, these features will be actually combined together to actually uh, form the images, actually the high level image. So now whenever the test data will come, then test data will come and some image, unknown image will be submitted. Okay, say this node is for say 9. Okay, so if this node is 9, then whenever test data will come, then it will follow this path, it will follow this path, and this it will be classified at this node, it will be detected at this node, because this node is designed for combining the features of the images of 9. So now here the different node will actually, different output node will actually learn the different pictures, different images of the digits. And hidden nodes will actually learn the horizontal lines, vertical lines, and also loops and this type of features. So now, so the multiple layers is actually makes sense because in our brain actually works in that way. So in the brain we have a multiple layers, and it is observed that it has many region in the brain, and whenever anything is actually goes through the brain, it is actually passes through the multiple layers, and different and we know that our eye is actually detecting the different types of images from the outside world, and then the signals is going through the different layers of our brain, and finally this is being classified at the higher level, whether this image is of certain kind or not. So this is actually, so that is why more likely the deep learning is actually known as a deep brain or deep mind, because the working procedure is a little bit analogous to the working procedure of our brain, though they do not work in the similar way. So now many layer neural networks architecture should be capable of learning the true underlying features and feature logic, and therefore generalize the variable. So it is actually, so previously I mentioned that what is actually called the deep learning and deep neural networks, and it is a deep neural network because it has a multiple hidden layers. So if you have more than two hidden layers, then it is called a deep neural networks. So it has a 1, 2, 3, 4, 4 hidden layers are there. So now it is observed that whenever this type of deep neural networks is actually trained using backpropagation algorithms, so it suffers from the problems which I have mentioned earlier, is a gradient vanishing problem and gradient explosion problem. So now to cope up with these situations, the Hinton, who is known as the father of deep learning, he has introduced a method uh, mm, which is actually greedy approach. So this greedy method was proposed by Hinton, and he observed that if this kind of deep neural network is trained using some greedy method, and then the the gradient vanishing problem and also the gradient explosion problem can be resolved to some extent. And he also experimented with the MNIST dataset, and the performance of the his proposed model is actually outperforms all of the existing deep model, neural network model, by high margin. So I will now show you how what was the idea that was actually introduced by Hinton for uh, dealing with the gradient vanishing problem. So uh, so the idea was that the layer was training, the layer wise training. So it was actually the layer wise training, and this is actually the layer wise training. So it is actually the greedy layer wise training because initially uh, the layer, I mean that this layer will be trained first, and then this layer will be trained, then this layer will be trained, and this layer will be trained, and finally this layer will be trained. To train the first layer, this layer first, and then the second layer, third layer, fourth layer, and the final layer. So it is actually known as a layer-wise training. And then now the question is, then the after uh, doing this, I mean, by training the first layer, second layer, third layer, and fourth layer, and the final layer, finally they are combined together to have the final trained network. Now the one of the question that will come in mind obviously, that how to actually train the layer wise, this layer separately, because we know that the backpropagation algorithm is actually works over the entire uh, network. So how this segment, I mean certain segment of the network can be trained without hampering the other portion. Okay. So Hinton introduced a new technique, which is actually known as a, which is actually a kind of model, which is actually known as a generative model. So this is, and one of the basic idea which was introduced by Hinton was a Boltzmann machine. But I am not going to discuss the Boltzmann machine here. So most simplest way of implementing the Boltzmann kind of thing is an autoencoder. So the autoencoder is actually used to train each of the layers separately, and then the entire network segment can be interconnected with each other to develop the final network. And before going into the detail of this layer-wise training, you should know a little bit about how the autoencoder works. So an autoencoder is trained with an absolutely standard weight adjusting algorithm to reproduce the input. So for example, if your input is an image and if your output is also the same configuration of the image, and then if your hidden days is less than the number of nodes at the output node and the input node, then a concise representation or dense representation of the input will be made at the hidden layer. Okay, I mean, input, you are trying to if this network is a small network. This small network is actually trying to reconstruct the input and the output. So if you give the input as 0 1 0 1, you are trying to reproduce 0 1 and 0 1 at the output also. So in the autoencoder, the input and output would be the same, and hidden layer, a number of hidden nodes should be uh, less than the number of input or output layers. So if we do this, then what will happen? If we do this, then this input will be condensed into a lower dimension that is sufficiently enough to reproduce the output. In other words, in the hidden layer, the most salient information from the input should be captured so that it can produce the output. This is the idea. It can produce the input again. It can reconstruct the input again. So it is a summarized version of the input. It is the essential component of the input that is required to reproduce the input again. So if we can do this, then the high dimensional input can be represented as a low dimensional space, and thus this layer can be trained. I mean, this is the layer, and this input to hidden layer, this is the hidden layer. So thus this hidden layer can be trained. So now, by making this happen with fewer units than the units inputs, that this forces the hidden layer input units to become a good feature detectors. So it will actually detect the important features from the input. Now, now I will show you how the autoencoder is actually applied layer wise. So intermediate layers are actually trained through autoencoder. So just you go to this. So you use a autoencoder here separately, separate autoencoder here. And this autoencoder, what the autoencoder will do? Autoencoder will actually take this hidden node and this input nodes at the output also, and it will try to train using backpropagation, and then it will adjust the weight so that there is some condensed representation at this hidden node. After that, you now use this autoencoder 2. Now the input produced, the hidden node representation which has been produced using the previous autoencoder, that will be now the input here. And now this will be now trained using the autoencoder, this node. And in that case, this will be the input, and this will be also the output, and this will be the hidden layer. Now, in this case, there's another autoencoder, and this will be the input. The output generated in the previous autoencoder will be the input now, and then output. I mean, output means the hidden information. Hidden information generated by the previous autoencoder will be input here now. And now another autoencoder will be applied, then this autoencoder will apply, then another autoencoder will be applied. Finally, this autoencoder, this network will be now connected together. And wherever this network will be connected together, this connection weight should be actually used from the autoencoder 1. This connection weight will come from the autoencoder 2. This connection weight will come from the autoencoder 3. And this connection weight will come from the autoencoder 4. And this connection will come from the autoencoder 5. Now the entire network will be constructed in this manner. And finally, the fine-tuning operation should be made. In fine-tuning operation, this entire network will be now fine-tuned with the traditional backpropagation algorithms using the training dataset. So this is how the gradient vanishing problem can be handled to some extent, and the performance of the deep neural network will improve. So now, what is the idea? The main idea is that this solution was given by this kind of network is actually known as a deep networks, and this idea is this is actually known as a pre-training. Okay, this greedy layer-wise greedy training is actually known as a pre-training. So the pre-training should be meant. So now, if you just look at this diagram, then you will be able to identify why the deep leaf networks is actually performs better than the traditional backpropagation. Say for example, this is your input, and now if you apply the random initialization of the neural network, if you apply the random initialization of the random network, then you can get the good solution, but this is actually the total time. This is the total time that is actually required. The red arrow. Red arrow is actually a very slow backpropagation, and also often gets stuck at a local minimum. Okay. So now your performance may also fall due to this reason. And but if you apply the pre-training and first supervised pre-training algorithm is applied, and the autoencoder is nothing but an unsupervised pre-training, because you try to understand how the autoencoder is actually working, because you are submitting some input to the autoencoder and you are trying to regenerate the output. Okay, so there is a no level at the output. Actually, you are not using the level of the data at the output for whenever you are using autoencoder. So we can say autoencoder is an unsupervised pre-training, and then uh, you are gradually getting this weight vector, and your solution is becoming very quick. I mean, this portion, the pre-train, whenever you are pre-training the model, this is you are taking you to the close to the solution point, very close to the solution point, and whenever you are fine tuning, you are quickly getting the solution. This is the idea. So using the pre-training, we are becoming very close to the solution point. And now, whenever you are applying the fine tuning, then you are quickly getting the good solution. That is why the deep leaf networks, or which is actually known as a supervised, which is actually deep neural networks, and that uses the layer-wise pre-training that performs better than the traditional dark population algorithms on deep neural networks. So this is the first paper that was actually Hinton proposed in 2006, and this paper is actually, and it is actually the result that is actually was reported by the Hinton in his paper. If you use a one header layer, and if you apply the 1 hour training, then the performance improvement 2.18%. The error rate is 2.18%. And if you 14 hours training, the error rate will be reduced. I mean, error rate 1.65%. But if you use the DBN, the 1 hour training, if you use the 1 hour training of this in Intel quad core 2.83 gigahertz 4 GB RAM and MLP Python DBN MATLAB, then it is observed that it will be actually 1 hour, after 1 hour, your error rate should be on a MNIST dataset. There is a handwritten numerals 1.6%, and after 14 hours it will be 1.10, but 21 hours, it should be 0.97%. So it is a huge improvement, because error rate is becoming less than 1% and very close to 100% whenever if you apply the DBN. So this is actually the first paper which was introduced by the Hinton, and most likely this paper is actually this one, Hinton, a fast learning algorithm for deep leaf networks, the neural computation 2006. That was the paper. And you can consult this paper to know about the detail of this procedure that I have presented here. And after that, there is a different types of improvement proposed by the different type of researchers from time to time. So there is an excellent tutorial given by Hinton on deep leaf networks. There is a machine learning summary school, Cambridge 2009. So you can also go through this tutorial. That is a tutorial on deep leaf networks, and then you can get a good idea how the deep leaf networks works and with the philosophy behind this. So this is in short the introduction to deep neural networks, but there are,
'Different types of deep learning techniques now at this moment.
different types of deep learning techniques now at this moment. So if you think about today's improvement, then some of the points I should mention, but I will not be able to discuss here because the time is limited, and also I have to cover a lot of things. And our time is we have only 1 or 2 weeks time to cover the entire machine learning. So some of the improvements and some of the other kind of networks which are actually used for deep neural networks, that is the CNN, and this is actually known as a convolutional neural networks. And that is another is RNN, recurrent neural network. So the most improvement, the recent improvement over the recurrent neural network is actually the GRU, and GRU is a gated recurrent unit. And also the LSTM, LSTM, that is a long short-term memory. This is the recent improvement over the deep neural networks. But and if you want to be expert in deep learning, so I will recommend you to the tutorial by Andrew Ng, the tutorial by Andrew Ng on deep learning. Particularly CNN, you can follow this tutorial, excellent tutorial, but it is actually not possible for me to discuss everything now at this moment. And also, so this video is actually very important videos. This is a computer vision, deep learning AI, and there are different types of, especially the convolutional neural networks is there, and
স্যার ভিডিওটা দেখতে পাচ্ছি কিন্তু শুনতে পাচ্ছি না কিছুই আসলে।
ও, যেহেতু আমাদের এটা অন করা আছে তাই জন্য হয়তো শোনা যাচ্ছে না, হতে পারে। However, so now what we would like to say is that this is a very excellent video, and now if you want to learn in detail how the convolution neural network works, so you can go to start from the beginning. And if you go to this, at least this up to this, I think up to this, okay, up to this classic neural networks, so you will get a clear idea how and why the convolutional neural networks is useful, especially for images and image classification tasks. So what we would like to say is that this is a two-dimensional image. The bigger matrix is nothing but a matrix representation of an image, and this is called the filter. The small one is called a filter, and this filter is being applied on this image to actually map this image to a lower dimension. And this is the actual weight of the filter 344102 minus 103. This weight has been actually assigned manually, so which pixel will be given the more weight. So I have previously mentioned that there are different type of features: horizontal line, vertical line, and also there are different types of circle features are there. So what type of feature you want to extract, that depends on what type of filter you are using. Okay, so now this filter values can be manually put here, or this can be automatically learned using the CNN network. So using this filter, we can concentrate on the horizontal lines, vertical lines, loops, and different type of features of the input images, and we can map this image into the lower dimension. And finally, whenever the next layer of the convolution network comes, this will we may go through more and more many convolutional layers, and more fine tune this information may be more fine tuned, and the salient features may be extracted from the input. So one of the important point is that the traditional neural networks and CNN is that this is actually this can it is can it can do automatic feature learning. automatic feature learning. So if you try to compare that in case of previous layers, in case of deep neural networks, you are submitting the pixels, okay, and now the pixels are actually the features. But in this case, actually, the convolutional neural networks is actually automatically extracting the features from the images. Okay, so it is actually the automatic feature learning. So convolutional neural network has this capability to deal to extract the features from the images automatically. And uh, the recurrent neural network is actually useful for a certain kind of input processing certain kind of data, which is actually known as a sequence data, or the time series data. Sequence data. So this kind of network is actually useful for sequence processing the sequence data or the time series data. So this requires the totally separate lectures. I mean the at least the just to look at how many lectures are there in this presentation. Only the CNN has total just to look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 4, 25, 26, 27, 28, 29, 30, 31, 32, 3, 4, 5, 6, 7, 8, 9, 10. So 40, 41, 42. So roughly there are 42 lectures, and after an average time is say it is 10 minutes. So now it requires 400 roughly the 400 minutes. So 400 minutes means it is actually 60 into I mean 3 hours, 6 hours, 6 hours. 6 hours means equivalent to uh, mm, three classes. Okay, three full classes, and um, and also the RNN will take another 6 hours. So minimum 6 hours, 6 classes. So 6 and 6, so 12 classes. So at least 12 classes is required to cover the CNN and RNN. So I will get more likely total 6 classes up to March. So I have to cover the decision tree learning, Bayesian networks, and also some other document class. I mean that data clustering, so many things. So deep learning cannot be actually taught further. So if you are interested, you can follow this tutorial. And if you have any question after attending this tutorial, then you can ask me. Then I will try to give you an answer. So this is actually the end of deep learning and neural networks. And now I will gradually move to our according to our syllabus. So now I will now highlight another type of this another type of machine learning algorithm, which is actually known as a decision tree learning algorithm. Decision tree algorithm is very old. I mean, it was actually given by Quinlan in 1969 around. Okay, so you try to guess how old this method is, but still it is relevant and it is also useful in many applications. So now the question may come in your mind, if this algorithm is very old, so why this algorithm is actually uh, still useful in many applications. Particularly, it is more useful for medical applications. Okay, so that will be clear whenever you will observe that the features of this type of machine learning algorithm, and it has a important features, and that will be clear to you. So now, initially, the algorithm given by the Quinlan is actually known as a uh, ID3 algorithm, and gradually it was improved. So after that, the 3 C4.5 version of this improvement version of ID3 was given, and then finally C5.0 is also available now. And um, just to try to understand how the hypothesis function is look like for neural network and also the তো এখানে ট্র্যাডিশনাল যে মেশিন লার্নিং অ্যালগরিদমগুলো আমরা দেখেছি আর এখানে যে অ্যালগরিদমটা এখন দেখতে চলেছি কিছুটা ডিফারেন্স আছে দেখা যাবে তার পদ্ধতিগত দিক থেকে এবং তার আউটপুট জেনারেশনের দিক থেকে। So now just to try to think about the traditional a node of a ANN and a small decision tree. What is the difference between these two? Just to think about this. So now you try to recall this is a node of a neural network and and if you try to recall the XOR function, okay, how the network look like. For the XOR function, the network was like this. It was the network for a XOR function. This was the function of XOR network, a XOR function, and what was actually the hypothesis function in this case? Can you tell me the hypothesis function for this type of network? If the nodes are linear, and say it is a W1, it is a W2, it is a W3, it is a W4, it is a W5, W6. Then what would be the actually the hypothesis function for this network?
H1 equals to W1 x1 plus W2 x2.
Right. So now I'm writing in this fashion h, a small h, and I'm writing is a h, not writing h theta, I'm writing h theta w. And that x, now say this matrix, this is the weight matrix, okay, w is weight matrix and x is the input. Then can you tell me in matrix notation what would be the matrix notation?
W transpose X.
Right, it should be w transpose x. That should be the hypothesis function, but if I consider it is a W1, it is a W2, it is a W3 and W4, okay, and it is a W5 and W6, then this should be actually, it is X1 is X2, then the hypothesis function will be look like this. Say for example it is X1 and this input is X1. X2 and say it is a W1. It's W1. The W2. Say this connection is W4. Though this is not the way to give the convention. Traditional convention is something else. So it should be 1, 2, and that should be W1 and W2 like this. But I am giving, since there is a few number of connections, so I am giving the name like this: W1, W2, W3, W4. But I have previously mentioned that according to the general convention, that should be actually 1, that should be 1, 2, that should be 1, 2, that should be W11, and that should be W21, and that should be this connection should be actually W22, and this connection should be actually W12. So traditional convention. But since there is a few number of connections, so I am saying the W1, W2, W3, W4, and then this is actually W5. Say it is W5. But this also will be different, and we have to apply the layer here, the layer 1, layer 2, that is also 1, 1. It is also 1, 2, W12, and it is a layer output layer, it is a layer 2, it is a layer 1. So I'm not using that complicated notation here, but that is a convention actually. So this is a W6. So logically, the h theta x should be actually the W1, that what is actually produces this W1 x1 is there, and W2 x3 is there. This. So now that should be a linear combination here, but it is a linear node. So the first should be actually the W1 x1 plus W3 x2, and the second one should be x1 W2. I mean the W2 x1 plus W2 x1 plus W4 x2. W4 x2, that will be the input here, and that will be, now that will be multiplied with this one. This 2 will be multiplied finally. This is a summation here. This is one summation here, and another summation is here also. is to summation. This is to summation. Now this is becoming input here. So that will be multiplied with W5 and W6. This will be multiplied by W. So now it will be multiplied by W6, W5, and this will be multiplied by W6. This is the hypothesis function. So it is clear that this is a linear. So I have previously mentioned since all the nodes are linear. So this hypothesis function should be actually linear. So you can do a little bit better look by choosing the superscript, subscript properly. So essentially it can be written, in this case it can be written as a some constant into x1 plus some constant into x2. We can write in this manner also. So it is essentially linear. So I previously mentioned that if you take all the nodes are linear, the network will be actually essentially linear. So however, for this network, if the all nodes are linear, this is the representation of the hypothesis function. And you try to recall the what would be the weight value and the threshold value here. There is some threshold. I mean the bias neurons are there also. There is a bias neuron connected with this, and there also a there should be a bias neuron here. This is the bias neuron, nothing but a bias neuron here. There is a bias neuron here. And the value of the bias neuron is always 1. Input is always 1. And you try to recall how I have manually assigned some values to W1, W2, W3, W4, W5, W6 whenever actually, and there was also some weight value here and some weight value here also. This connection also. This is the input to this connection, but there's some weight value here for this node. So it is actually the exclusive or XOR neural network. So, and this is the hypothesis will look like. But if you use a decision tree, then how the hypothesis look like? Say if you try to recall the table 4x4, 5x5 table, that is actually the truth table for XOR function. So this is your input A1 and this is your two inputs. So one input A1 and A2. And what say it is X1 and X2. Now oh, it is 0, 0, it is 0, 0. Then what would be the output for XOR function? Both are 0.
1.
0 or 1?
on
जीरो और तो ऑड वन डिटेक्ट कर सकता है इसलिए
Zero.
sorry sir 0
So now it should be 0. Now it is 0 1. It should be
on
वन सर
1 0.
वन
And 1 1.
जीरो
Okay. So now if this is a function, this function can be using the linear neural network, this can be represented. But using a decision tree, this can be represented in a different way. The hypothesis function for this decision tree will look like this. The 1 minute. Huh? Ball. So now your neural network will look like this. Say for example, this is your node, and this is root node, and now this is actually a branch. Is also another branch. Now the shape of the first node is actually x1, the attribute. First node is the attribute. Now the x1 can take the value, two value, either 0 value or 1 value. It is attribute value, so it can either take, x1 can either 0 value or 1 value. So we are creating two branches. One for the 0 value, another the 1 value. Here also there is a x1. So it is actually I say it is actually 0. The branches are actually labeled with the values of the attribute. These are nodes are the attributes and branches are the values. Here the all attributes are binary. All attributes are Boolean attributes. So this is actually the branches, the two branches are created because the x1 can take either 0, 1 value or x2 can take the 0, 1, 1 value. So the number of branches is created. How many branches will be created? That depends on the values of the attributes. So এখানে প্রত্যেকটা অ্যাট্রিবিউট যেহেতু দুটো করে ভ্যালু দিতে পারে ম্যাক্সিমাম, সেই জন্য এখানে দুটো করে ব্রাঞ্চ ক্রিয়েট হয়েছে। বাট ইট ইজ এ মাল্টি মোর ভ্যালুস, এখানে যদি আরো থাকতো আরো ব্রাঞ্চ ক্রিয়েট হতে পারতো। সো নাও so this is now you can say it is a no, and you can say it is yes, and you can also say it is yes, and this is no. Now you try to classify your training data set. I mean you will get 100% results because if you give the 0 0 here, now these branches will be found 0, x1 equal to 0, sorry, x1 equal to 0, x2 equal to 0, then classification no, yes, x1 equal to 0, x2 equal to 1, x1 equal to 0, x2 equal to 1, classification yes, yes, you can represent this as a you know, this as a 1 as a yes, Whenever there's a 1 0, so 1 x1 1 and x2 is 0, x2 is 0, so it is yes. So both are 1 and 1, you know. So using a decision tree, it is actually nothing but a decision tree classifier. So using the decision tree, we can classify all these data points. And the XOR function can be implemented by the decision tree. So just to try to compare, here the hypothesis, how the hypothesis is represented here. Here this is the hypothesis, and based on this hypothesis, you are classifying whether it is depending on some threshold value, whether the value is greater than some threshold value. So whenever the value of this is greater than 0, it definitely should be some W0 here, but I have not mentioned the W0, but W0 should be here. And 2 W0 is there, 1 W0 is there, and another connection will be there, 2 W0 is there. So I have some mentioned W01 here. W01 here and W02 here. This is also the bias weight is there. Two different bias weights. To make it different, I have using the 01 and 02. So this bias and this bias. So in this case, how the decision is taken whenever this is greater than if this is greater than or equal 0, then yes. Otherwise, no. This was how the neural networks classifies the input. But if you look at this, after developing the decision tree, after generating the decision tree, when some unseen data comes, the decision tree will actually, depending on some input pattern values, it will matches the values with the values of the branches. So if you give the 0 as input, then it will match the 0 with this branch, and then go to this next value will be matches with the this branch, because it is an attribute 2, and this will be the output. But what is doing here? This is simply comparing these values here with whether greater than threshold value or not, and then deciding the one is. So in this case, the hypothesis function is our decision tree. Is this concept clear? I mean, how the hypothesis function is represented in case of decision tree learning, in contrast with the neural networks. Hello?
Yes, sir.
Yes, sir.
হাইপোথিসিস ফাংশনটা কিভাবে রিপ্রেজেন্টেড হচ্ছে নিউরাল নেটওয়ার্কের বেলায় আর ডিসিশন ট্রির বেলায় সেটা আগে বোঝার চেষ্টা করা, তারপরে হাইপোথিসিস ফাংশনটা হাউ টু লার্ন দিস। নাও দ্য সেকেন্ড কোশ্চেন ইজ হাউ টু লার্ন this hypothesis function for decision tree learning. This is the next question. But if the question is put here, how to learn hypothesis function for NN, what is the answer? What is the answer?
Back propagation.
BP algorithm. This is the answer. This is the answer. And how to learn the hypothesis function of decision and given the ID3 algorithm. That is not yet discussed. But I'm trying to make the idea clear actually. What we are going to do actually. If it is this not clear, then the next portion remains very vague. যে কি করতে চলেছি সেটা যদি না বুঝি তাহলে কি করছি সেটা বোঝা যায় না, বোঝা খুব ডিফিকাল্ট হয়ে যায়। তাই জন্য কি করতে চলেছি, কেন করতে চলেছি সেইটা আগে বোঝা খুব জরুরি। মোটিভেশন শুড বি ক্লিয়ার ফার্স্ট, and then you go through the procedure, etc. So in this case, in the case of decision tree, the hypothesis is done using the ID3 algorithm. এই যেটা বানিয়েছে manually, simply manually, since there is a small amount of data, manually it has been created. হাতে হাতে বসে বসে ভেবে বার করেছি। কিন্তু if the data becomes very large and dimension is increases, it is also similar argument is also valid for XOR function for neural network. You can manually assign the value W1, W2. Okay, but if the data set increases, then you have to apply the VP algorithm. So if the data set increases, then you have to apply the ID3 algorithm for that. So another important difference is that one of the important differences is that decision tree is the hypothesis representation in case of ANN and in case of decision tree is totally different. And third difference is very important difference. Say the neural network has the ability to handle the numeric input. Okay, so here the input can be either input can be either continuous or discrete. But here this input must be discrete. Okay, this is also another. And now, so far it looks that the ANN algorithm is superior to the decision tree learning. But one important part is that in case of ANN, what is inside this hypothesis function that is not visible at the time of taking the decision. Okay, whenever you are some unseen data points, you are going to classify some unseen data points. You do not know actually why this is actually classified as yes. If the question, so it can the why an unseen stance is classified as yes or no. I mean that why what makes the input to be classified as input as yes or no. What makes sense? Okay. So now, what makes this input to be classified yes and no? So I mean the what is inside this function actually? Okay, so that is not. So this is not explainable. Not explainable. This is not explainable. But here, whenever you are saying yes or no, you are saying yes or no. That is explainable because it is yes because the value of x1 equal to 0 and value of x2 equal to 0. That is why it is actually. That is why it is no. Okay, so you can explain this manner that input is 0 and both input is 0, so the output is no. If one first input is 0 and second input is 1, so output is yes. First input is 1 and second input is 0, so output is yes. First input is 1 and second input is 1, that is why output is no. So you can explain this way, but in this case you can only say it is a greater than threshold value, so yes. It is a less than threshold value, so no. So it is more explainable. So this output is, this model is more explainable. Just to take an example, so for medical applications, some say for example the cancer classification problem. for certain input, for certain input, for certain input, say input image, say the model says yes. Now immediately the doctor may ask the question, why? I mean, due to which symptoms you are saying so? This question may come in the mind because the doctor wants to compare the decision, or better say validate, the decision given by model with his or her experiments or domain knowledge. So, in case of neural network, it is not easy to understand actually why this is saying that. It is saying yes because the value is greater than threshold value, but it is no value less than threshold value. But which symptom is more responsible, and how actually neural network is saying that this certain cases is a cancer or not, that is very difficult to conclude. Okay, but in case of neural network, if it is yes case, then it can easily identify which path is actually followed, and it can say that this is the reason, this symptom is off and this symptom is yes, that is why it is saying yes, and this symptom is yes and this symptom is yes, and that is say it is no. So quickly this is actually explainable, and the decision tree DT is more interpretable than ANN. So in today's world, the latest research is going on, that is which is actually known as a explainable AI. This is actually known as explainable AI. So from this point of view, the decision tree is a better classifier than the ANN or even the deep neural networks. It is one of the important criticism regarding the deep neural network is that deep neural network is performing better in many domains than the other existing model. In fact, than decision tree learning, but this is not explainable. So from the explainable AI perspective, the decision tree learning is a better algorithms than the artificial neural networks. So this is the point that to be noted, because in recent times, in many research papers, you will see that the models are being proposed, and the reviewer is asking that whether your model is explainable or not. Simply giving the more accuracy, I mean the 100% accuracy or 99% accuracy, does not indicate that your model is explainable and that is useful in practice. I mean, not from beyond the academia. And this happens also in case of market. I mean the market, different types of product recommendations or different applications, which is actually used in the industry also, because sometimes some product, okay, some product is actually not high rated product. Okay, so definitely the company will try to know what is the reason why the people actually, due to which features, and due to which features the common people are not actually preferring to our product. So this explanation is required. Otherwise, AI cannot be acceptable by the common people, and AI cannot be acceptable by the common. I mean, the different type of industry. And it is also another criticism that in many areas where the security is an issue, and where the companies are very concerned about the security, so for the banking sector, they may not be satisfied with the output of your model only. They may want to investigate why the model is, say for the fraud detections. So you are developing a machine learning model that is actually saying that it is actually this application, this is a transaction, it is a fraudulent transaction. Okay, now whenever the bank has to take some action, action against the hacker, then the bank has to explain why the machine, why the bank is actually taking this charge against the hacker. Okay, otherwise bank will be in very bad position. Okay, so if the bank says that no, my machine is saying that he is a fraud, then the court may not agree with that. So bank has to produce some evidence, and bank has to explain why it is a fraudulent transaction in front of the court. Otherwise the banker will be put into the jail. Okay, so in the total research in machine learning is now little bit and changing its direction, and it is now not only the accuracy issue, and then you have to concentrate on the explainable issue also. And the AI techniques and also the machine learning techniques has to prove that this is explainable. So from this perspective, the decision tree learning is a better algorithm, though the accuracy of these algorithms may be sometimes, for some applications, not for all applications, for some application may be very poor. I mean, the poorer than the deep learning model. So in the next class, I will discuss, because at 5:12 I will be very overdose for you. So the next day I will discuss. So the motivation is now, I think, clear why the decision tree learning algorithm is a very useful for different types of practical applications, especially medical application, as also the industry, and data mining applications also. And then in the next class, I will discuss how to learn the hypothesis function for decision tree learning using ID3 algorithm. I mean, how to construct the decision tree from the data automatically. It has been not done. It is not done automatically. It has been done manually, because this is a limited amount of data, and I have created this decision tree manually. But if you have a huge amount of data, this can be generated automatically. So how the decision tree can be generated automatically from the data using ID3 algorithm, that will be discussed in the next class. Okay, so do you have any question? Then you can put the question. কি কোনো কোশ্চেন নেই, কেউ কিছু বুঝছে না, বুঝছেই না মনে হচ্ছে কোনো কোশ্চেন নেই, মানে কেউ বুঝছে বুঝছে হয় সবই বুঝছে নাহলে কিছুই বুঝছে না। হ্যাঁ? ঐশিক চন্দ, are you listening? Oishik?
Yes, sir. Huh, sir.
So is this idea clear? What is the basic difference between ANN and decision tree?
Yes, sir.
Okay. So this is the first time for you that you are learning machine learning.
No, sir. Actually, I took a basic course for the Andrew Ang one only. So I
Okay. So Andrew course does not include the decision tree learning.
No, sir.
Okay. Mahabub Alam.
Yes, sir.
So what is about you? What is about? Are you getting it or not?
Yes, sir.
Okay. So you have any prior knowledge on machine learning?
Actually, no, sir. But I learn about uh, privately in after complete the course BTech. I learn ML.
Okay. On the internet. Huh?
Yes, sir.
So decision tree learning is new to you, is it?
Yes, sir.
Because it is normally not available on the internet because it's a very old technique, but it's still relevant. Shubham,
Yes, sir.
so what is your do you have any prior knowledge on machine learning?
So yes, sir. Actually, I worked on some projects related to ML, but this decision tree learning, I mean, it is new to me also. Not worked on this.
Okay, Somo Banerjee.
Yes, sir.
So is this your first knowledge, or you have already done something on machine learning?
Sir, I actually did the Andrew NG course, but I have never seen this decision tree learning in that course. So,
No, it is not part of that course actually.
so the decision tree learning is new for me.
Okay. Aniruddha Maiti.
Yes, sir.
So have you any prior knowledge on machine learning?
Yes, sir. I have something. I mean, little bit, not fully.
Okay. So Omit Kumar Mondol. Omit, what is about you? Are you getting it? What I am teaching? No sound. Onidho Maiti is already the Opu Sarkar. Aniruddha?
Yes, sir.
তোমাকে জিজ্ঞেস করলাম।
What, sir? Can you please repeat that?
Okay, so do you have any prior knowledge on machine learning? Or this is the first
Yes,
time?
sir. I have a little bit. I have knowledge about machine learning. I have done a course in NPTEL, Dr. Sudipta Sarkar, IIT Kharagpur.
Okay.
I have little bit knowledge.
Opu Sarkar?
Yes, sir.
This is the first time, or you have already learned the machine learning before?
I have little bit basic knowledge of ML, but don't have any decision tree learning is first time, sir.
Okay, Odindam Chakraborty? Odindam? So, what I am teaching, are you getting it or not?
Yeah, sir.
Okay. Oritra Poddar?
Yes, sir. Yes, sir. I'm getting it.
Okay, so have you had the course before?
No, sir. Not that much, but I have completed a course on NPTEL, and sometimes I Googled some terms about decision tree during after my BTech. So just about the basic knowledge.
Bikash,
Yes, sir.
what is about you?
Sir, it is new for me. I have learned basic of machine learning in BTech level only, sir.
Okay. Vishwajit Das.
Yes, sir.
So have you had this any knowledge in machine learning?
No, sir, it's totally new for me. Actually, I'm learning from NPTL now,
Okay.
and you also.
Okay. Diganto. Diganto Kumar Das. What is about you, Diganto? Not audible. Jyotiparna Bhattacharya.
Yes, sir.
So is it your
I
first?
know basic. Yeah, I know basic machine learning from internet, but decision tree is new for me in machine learning.
Okay. So my question is, are you getting what I am teaching?
Yes, sir.
Full stop. Full stop.
Yes, sir.
So what is your status? I mean, are you okay
Yes,
with
sir.
me? Huh? Are you getting what I am teaching? Because I have covered a lot of things already. I have covered the decision tree, the linear regression, logistic regression, artificial neural networks, little bit deep learning. Okay, so many things I have covered. But you keep in mind that most likely those who have actually followed the Andrew ENG on some other, they did not find Hinton's first paper on deep learning. I mean the greedy pre-training model or deep leap networks. It is not a part of the tutorial given by Andrew ENG under the
Okay, sir, I
syllabus.
got it. The reason three, not the part. Sir, logical regression. I am having problem in logical regressions.
You have some problem in the logistic regression, not logical. It is a logistic regression.
Yes, the logical regressions.
You have some problem.
Yes, sir.
What type of problem you have?
I cannot understand it, getting it actually. I have to watch more videos.
So have you gone through the videos of Andrew ENG on logistic regression model?
No, sir, I have yet to watch.
Okay, so I am recommending you to follow those videos. Okay, and because I have already followed the for this particular topic, I have followed the notations and also the logistic regression model as presented by Andrew ENG. Okay, so it will be very helpful if you follow this video, and then if you are not able to finally understand after attending the Andrew ENG's video, then you can tell me, then I can help you.
Okay, sir. You told which videos to follow?
Andrew
There was some network problem.
ENG.
Could you pardon
Andrew
me?
ENG.
Okay, sir.
Okay, he has a tutorial on logistic regression model.
Sir, I just understood the hypothesis of the logistic regression, which tends is the limit.
Okay. You have some problem. So if you have any problem now, you try to attend those tutorials, because I have exactly followed for this logistic regression model. I have exactly followed the notations and everything, which is actually given by Andrew ENG. Okay, so if you follow this tutorial, then that will be very helpful. Still, if you have any doubt, finally, then you can consult with me, because I have already finished that topic. So it will take time if I come back again to that topic again. So because I have to cover a lot of things, I mean the decision tree learnings, and also the Bayesian learnings, and also there are some different types of clustering data clustering techniques also. So that is why I am now saying at this moment you can consult the Andrew ENG video on logistic regression model, and if it is not possible, still if it is not possible after that to understand what he is saying also, then you can consult with me.
Okay, sir.
Mahabub Alam.
Sir, can you hear me? Sir, I was having a problem with the mic. Sir, I'm Diganto. Sir, what you're asking me, sir? I too did an NPTEL course. I know the basics of linear and logistic regression, but this decision tree is like a little bit new to me. Sir, I'm
So
getting
have
it.
you, the backpropagation algorithm that I have presented is clear to you?
Yes, sir. Almost. Yes, sir. I need to just go through the lectures and the slides one more, and it'll get better.
Okay, okay. Now, okay.
Thank you, sir.
Meghna Chaudhuri,
Yes, sir.
what is about you?
Yeah, I'm getting whatever you are teaching, and I'm also having some basic knowledge in machine learning from because I had this subject in my BTech final year.
Okay, so the backpropagation algorithm is clear to you or not?
Yes, sir.
Pinaki Katkun? Pinaki? Okay. So